Hello, welcome to the in-depth OMERO How to View Data tutorial. This is a short video to familiarize you with online image data that's been curated and made available through the Cost Action Consortium called INDEPTH. This is the INDEPTH homepage, and on the images subpage, you will find a link to this image repository that we call OMERO. So the plan is to have several of these, including several in Europe. And this first one that we've put together is called OMERO FSU, and you access image data through a web browser. So what's nice about this system is it's set up to be easily accessible, and this is so that people can view image data from publications or for teaching purposes. And it functions as a interactive repository, kind of like a sequence database where you can store images instead of sequences, and you can access them. So I just wanted to show you what it looks like and how to navigate particular images in a way that allows you to view and scale and change the colors. And you can even download data for subsequent reanalysis if you like. So the server is called OMERO. It's produced by the Open Microscopy Environment folks. And it's a free server that allows you to put data online. So when you click on that link, and I will just go back and click it one more time. It's at omero.bio.fsu.edu. So this is hosted through the biology server at Florida State University. And if you go to that URL, it launches you into the public view page. So you are actually logged in now as a public viewer, even though you don't actually have to log in. If you have an actual login credentials, you would click this button in the upper right. But for the general public, all you do is go to omero.bio.fsu.edu, and you will be brought to this opening page. And it has three window panes, a left, a middle, and a right. On the left are the folders and their contents. And as I click on them, you can see that the information pops up on the right. So these are folders and subfolders that have images. So what I want to do is just orient you with respect to how this is organized. So if for some reason you come to OMERO and this whole front page is blank, sometimes that happens, to see the data that's public, you click on this upper left window with the two people icon, and you choose in-depth public data, and you move over to all members, and you click that one, and it will refresh this page. So these folders are organized as teaching folders, training and benchmark folders, and then published data set folders. And they're given individual IDs, IDP data project folder 300123, etc. So if you click on one, first thing you'll notice is on the right, information appears. This is the information that has been entered into this folder. If you click on a subfolder, it has information. And this tells you a little bit about the purpose of the folder, its contents, and possibly links to other information. And then you notice that in the middle, you get thumbnails of the image data. So if you click on these one at a time, you will select different images. And in the middle window, you can select between thumbnail or this longer version. So the metadata is always on the right. The thumbnails are in the middle. If it's a really large folder with a lot of contents, there may be multiple pages that you scroll through. You can move through the data this way. This shows you a picture of the image, the name, the date, and the X, Y, and Z dimensions of this image data set. So if it's just one picture, there's only one Z section. If it's a three-dimensional data stack, there will be multiple Z sections. So you can tell right away this is a 3D data set. If you want even more metadata about the images, they're contained over here on the right. So these different sections have different drop-down menus that you can explore. Another useful feature is every image and every folder in the system has a link, and this chain link icon in the upper right will give you the link that you can copy and paste that into your notebook or a report, or just save it for later. So that will take you directly back to this folder in the future. So what I want to do now is just show you an example, and we will take from the teaching image examples just one of these. So I'm just going to click on one of these. And if you double click this image, it will open a new browser window showing you just that data set. So I've double clicked that image, and now that particular image data set is shown in a new tab. The original tab is still there, the data organized tab is there, but this is one particular image. And so here we see a nucleus that has been imaged in 2 different wavelengths. So I'm going to talk a little bit about how to view this image data, how to change the colors. It doesn't matter what you do to the colors and the scaling, the original image data is preserved. So don't worry about changing the settings here. So in this case, there's 2 wavelengths. They're shown as red and green, but you can change those colors here by choosing different colors. Magenta, for example. You can also switch between grayscale and color with this box here. So I'm showing you the controls on the right. They allow you to set the colors and the brightness and the scaling. And then in this window are controls for the size of the image, and then moving through the 3-dimensional data stack. So for the wavelengths, if you click on grayscale, it will show you one wavelength in grayscale image. This is how the image is actually collected. So most of these images, they're all different, but these particular ones are collected as photon counts using a digital camera. So there's a DAPI image with filters for DAPI and a fluorescein image for filters for green. So in the grayscale mode, you can choose one or the other. And when you do, you can see those images. And I think it's easier to illustrate the scaling, brightness scaling here. So to the right of that particular image wavelength is a pair of numbers which reflect the minimum and the maximum for the scaling. And there's a scale bar here that you can slide left and right. So as I move this scale bar from right to left, what it's doing is setting the maximum intensity to this number on the right. So that's not really the way you want to see it, but you can adjust this and play with these controls until you get it the way you like it. This is just linear scaling. And so what this means is that every pixel in the frame below a count of 188 is set to 0 or completely black. And every pixel above this number, now 4,513, is set to pure white. This allows you to isolate different structures in the data. For instance, you could slide this out here and see the brightest regions. In this case, they're knobs in the maize genome. But you can always go back to the full range or the imported range. And the imported range is just the way the data was uploaded. So I'm going to return the colors to magenta and green because they're easier to see. And that's how you adjust scaling. Over here is a slider that moves you through the 3-dimensional data. So the very upper left, there's a number 47. That is the number of optical sections in this 3-dimensional data set. So every picture is X and Y. That's what you see now. And then as you click through these arrow heads, I'm now moving through the data one optical slice at a time. And this is a nice way to just explore the data that's 3-dimensional. So all of this image rendering and display is occurring on the remote server in the cloud. So all you need to do this is a web browser and the web address, no special software. So one thing that's handy if you want to look through 3D data is start at section 1. So I've moved the slider to section 1. And this little arrowhead at the very bottom will step you through one slice at a time, and it moves at whatever pace it's able to move through. So now it's just clicking through all the optical sections, and that shows you the 3-dimensional data. This is a close-up of one nucleus. The big hole in the middle is the nucleolus, and this is DNA that's been stained for replication, the green. Another useful feature for 3D data sets is to make projections. These are through focus projections where multiple optical sections are added together. This little stack icon is for making projections. And I just clicked on it, and now you see there's 2 bars over here. So what is displayed is a projection of all the slices between optical section 19 and optical section 29. If we expand the stack, we show more of the nucleus. If we go all the way from the first to the last optical section, this is now a through focus projection of the entire image data set. So that's kind of how you explore 3D data. Different types of data have different structures, and so the number of wavelengths and their initial colors will vary. You can play with some of these other features. There's histograms for information. An important point about OMERO is that we often use it to store and view data, but this sophisticated analysis of the data is typically done separately by individuals. And so for that, people can download the original data set and open it in their own software. There are some tools for data analysis, but this is primarily a storage and viewing repository. So let's say you have an image and you'd like to save it, put it in a notebook, put it in a report. What you can do is 2 or 3 different ways to do that. One is you can just take a screenshot of what you're looking at. The typical whatever you have on your computer that captures part of the screen. Like this, I just draw a box over it, and I just saved a picture of that. Another way within OMERO is if you right mouse on the image, you can save what you're viewing as a PNG. So those settings, those colors, those scalings are now downloaded as a PNG, which goes to your downloads folder. Another way, if you want to actually work with the original binary image data, is to go back to the data column, the data view, and over here is a download button. And so for downloaded images, I would just remind the user to credit the source. Most of these are from publications, and in the folders there's information about where the data came from. And so like any other resource, if it's been published, please be sure to credit the source. So download here allows you to download this image, and you can just take the first download to get the original file as it was imported. You can get just the metadata, which are these dimensions, as a text file, or you can download it as an OME-TIFF format. This is the format that OMERO uses when data are uploaded from different types of data collection software. And this is one of the big advantages of OMERO. We've always had the problem that when you collect data, if your collaborator doesn't have the same software, sometimes you can't even share that data in the format that it was collected. So OMERO unifies all that and makes a standard format that's called the OME-TIFF format. So all of these can be downloaded. So I just want to show you, for example, these are published data sets. So this one is Dumer et al. 2019, and there's a note over here about that image data set. And here you have individual figures organized by figures, and then data within each one. Now the different types of data show up differently. For example, if we double click this one, we have 2 wavelengths. If you double click another one, it might be a different type of data. This one is a single wavelength. But again, we have the 3-dimensional data that you can move through or make projections. So the goal of this is to make these data sets available. The INDEPTH Working Group 1 has been slowly building this up. The way we're doing it is we're having people submit published data sets, and then the INDEPTH uploads the data for the sake of curation and allows people to then have a permanent repository of their data for future analysis. And so we are just starting this process, and you can see there's a few data sets here, but we are hoping to fill this up. And so we have a call out for INDEPTH consortium members who want to submit data from either publications or teaching. And for that, I think you may have already received an email from Paula Santos on how to do that. And basically, if you have a published data sets, if you can organize them and fill out an information sheet, then we will help you load them onto the INDEPTH public repository. And this way they become available, archived, and reusable for subsequent analysis. And so the teaching images are not necessarily from a single publication, but these are put here because this system at FSU was initially purchased to supplement teaching. And so, for example, I'm using this now in a classroom setting and having students do mitotic index counting just by going through this sort of 3D. This is a root tip data, for example. So with that, I encourage you to explore this data. Contact INDEPTH if you're interested in having some of your published data uploaded here. And thank you for your attention.